everybody today to my talk. It's the title is Deployment Options for OSGi Applications in the Cloud Edge. I'm coming to the idea of the title in a second. My name is Dirk Fout, as I was already introduced. I'm a research engineer at the ETAS Corporation, which is a 100% daughter. And as I see Jürgen laughing, yes, that's actually me, but I only have a very old picture of myself and my incredible PowerPoint skills. Well, I try to update the picture a little bit. Yeah, as a research engineer at ETAS, I'm allowed to look ahead of what we currently have. And this is why this presentation came up. So what's the motivation of the title, Getting OSGi Applications Ready for the Cloud or the Edge? We have the situation that we have a lot of Eclipse RCP-based applications in the field. We're making money with Eclipse RCP-based applications, actually. But there is a demand to go to the cloud. Oh, sorry, that was too fast. There's a demand to go to the cloud. So people asking us, or customers asking us, can you also provide your applications in the cloud? Well, coming from Eclipse RCP, the first sentence is, well, it's difficult because in the cloud you don't have a rich desktop application. So what can we do? There are different approaches like containerizing the whole application, which feels a bit cumbersome. Last year I evaluated a scenario to cut out the functionality of your Eclipse RCP-based application into services. And with these services, you can, if we use OSGi, we can have a command line application based on the same services. We can have web services with the Jakarta RS application, with the Jakarta RS specification. So from single source, we can create different types of applications. And then very fast you get the answer, well, the startup of Java applications is so slow compared to whatever, Go, JavaScript, and so on. And the second sentence is the size of a container for an application is too big. And if we consider moving our applications to the cloud, well, the cloud is just someone else's computer, and we're paying for everything. That also means container size, computing time, and so on. There are a lot more topics like runtime performance, memory consumption at runtime, and so on. I had only a look at small applications that do something on the command line. So you start your container with your Java application, it runs, then it's finished and done. So I only look at size of containers and startup performance, just to give the limitation of the talk. There is a lot more, but that would be a topic for a next talk probably. So I will start with deployment variants of Java because I learned myself that I'm not aware of every deployment variant that exists and bring that in conjunction with what's possible in OSGi. Then I have a look in general, what can we do with containers in Java, and I will show my small benchmark application and a conclusion at the end. And I also have an outlook to what's currently happening in the OpenJDK world. Let's start, and I hope I can talk fast enough to don't reach the bottom of the time. So our first deployment variant in Java, that's a very traditional one. We have a bunch of jars, we put them in a folder, and we start the application. That's how Java applications look like. What you additionally need is a Java JRE, at least, running on your system. Oh, it seems, no, okay, anyhow. We have the folders. We have, as a second point, the executable jar. So we can put all our jars together in a single executable jar, which makes it easier to deploy it because you only have a single file you need to send around. But again, on your system, you need a runtime. that executes your code. Since Java 9, we have the possibility to create our own JRE using JLink. And there's this nice thing called native executable with a GraalVM. I only evaluated GraalVM. We have a colleague sitting here in front who also provides JRE, you too. We have 2 colleagues in front here from the Jamaica VM. 6 colleagues, okay, it's getting more and more interesting. The Jamaica VM, which is also capable of providing native executable from Java. There are also other providers of this. Some of these providers doesn't exist anymore, I learned in the past years. But currently GraalVM is the most prominent because it's more or less open. So I evaluated this one, but I assume that's the same for all others too. So what does it mean in the OSGi world? If we talk about multiple jars in a folder, that's the typical deployment variant for an Eclipse RCP application. You probably all know this kind. Yeah, we have Java minus jar, we start the OSGi, we have our Eclipse starter. Here on the right side you see it's a list of a lot of jars, and they look like this because of the guy sitting in the back here, because in the past the specification jars didn't need to be inside by their own. There was an Eclipse service jar that combined all the interfaces. That's not true anymore and causes still trouble in my old existing examples. Anyhow, this is how it looks like with the jars, and that's pretty, yeah, that's a simple one. The executable jar is a bit more interesting, at least for people coming from the Eclipse RCP side, because an executable jar with Eclipse RCP is not very common. I'm not even sure if it's possible. Haven't tried it, but there's the guy that says it's possible. In the end, you're packaging all your jars in one jar, in one single jar, and then it's executable. It's provided via BND tools, which we heard already several times. I've also seen something using Spring executable jar stuff, but for us it's BND tools because we're in the OSGi Summit. The next variant is the custom JRE via JLink. That was introduced with the Java module system in Java 9, because then the Java runtime itself is modularized. So I can create my own JRE containing only the modules from the Java runtime together with my modules and dependencies, and I create my own JRE. Well, as I said, it's JPMS. JPMS and OSGi are not the best friends. Let's say it's politically correct. Especially, we need a module info class, additionally to the OSGi manifest data. But most of the existing OSGi bundles doesn't contain a module info class. Why should they? I mean, that's like, yeah, I don't know. And even in Eclipse, we have always automatic module statements in the manifest data, and they don't work with JLink. So JLink is complaining about automatic module names. And there are additional problems like numbers in package names and so on. And the fourth one, the native executable with GraalVM. Actually, we want a native executable. We have a closed world assumption. That means we need from the beginning what we need at the runtime. There are no dynamics at runtime. So all the bytecode in your application must be known at build time. When I try to create a native executable from an OSGi executable, I directly get several problems and exceptions that are firstly non-solvable. Like, for example, a null pointer exception, a null service reference is not allowed. Basically, it means the dynamic class loading per bundle managed by the OSGi framework is not supported by GraalVM. But I wouldn't stand here if there wouldn't be solutions for this. So the upper left, multiple jars, no problem. That works for years. The executable jar with BND tools is also something that works for years, but the custom JRE, so the usage of JLink and the usage of GraalVM, not possible with what we know. But there's a way how to handle, for example, the JRE stuff, the JLink stuff. We could add a module info class even to existing jars. You could use modetect, and this is I have seen in one project that is really going over all modules and dependencies and then adding the module info class to these jars. But that's a pretty intrusive change because you're changing something you consumed from open source and then you get some legal problems, maybe. Well, because you're taking something from open source, you change it. What's the impact of the license if you change it? That's a common discussion even in the Eclipse Foundation. And you also need a pretty good knowledge of the internals when you use this. But BND Tools has the JPMS support since last year, I guess. Sometimes last year, Raymond Auger, namely, introduced the JPMS support. Yeah, it's done via the BND Maven plugin, so we're adding, yeah, I made it red, so I can add the JPMS module info in the build process. And then add also in the BND run file this section. Sorry, I was too fast. What this actually does is it makes the executable jar generated by BND tools to a module itself. So we don't need to put that information on every single jar we consume. So we take the executable jar and make itself a module. And with this, I can simply start my application or build. Here is I'm using JLink and create my custom JRE from the Equinox app jar. That's the result of my BND build. And at the end, I have my custom JRE. So I can have my custom JRE, but not from the multiple jars, because there we have the module info problem, but from the executable jar. What about the native executable? There's a specification named OSGi Connect. Not to mix up with some pretty old Apache Felix Connect implementation that was similar as it, no, it was not really similar. The Apache Felix Connect from years ago was a lightweight implementation of the service component runtime. I was able to start my service, my OSGi service-based application also with this Connect. It was pretty fast. It was interesting. But now there's OSGi Connect, and OSGi Connect in our specification says basically you are able to start your OSGi runtime even without the runtime. Or without the full module layer. Sorry, the runtime you need, but you don't need the full module layer. So you can also start your application from class path or from module path like you do with a typical Java application. Now, if I'm able to start my OSGi application without the OSGi starter, I can also start my application in a way so that I can create a native executable from it, because I need to start from class path and not from the OSGi bundle loader. The implementation of OSGi Connect is Felix and Thomas from Thomas Watson, and he also has some pretty nice examples available, especially for different types of applications and topics. Yeah, and I created my native executable. Well, you can use the GraalVM Maven build plugins, but actually the problem is if you use them, you get a result that works on your machine, because if you create a native executable, it's dependent on the machine you compiled and created your executable. I used a multi-stage build with Docker, so I can directly build for the target architecture inside Docker. One other thing that's currently bit unnice is you currently need the Thomas lib folder with all the included jar files next to your native executable, so the OSGi Connect implementation can resolve the metadata at runtime. Now it would be even possible with introspection. That's now supported in GraalVM, but I think it's not yet implemented. There's an open ticket to support this. That would make it easier. Yeah, if there's someone interested, I think the project would be happy if there were some feedbacks on this. But that said, it's now possible to also create a GraalVM from the jars itself using a Thomas Connect. OSGi Connect, Felix Thomas, too many names. Interestingly, it was not possible to use the executable jar then, if I have OSGi Connect included in the build process, the executable jar does not start. I opened a ticket, had some discussions with it, and it's probably because of the loading inside of the executable jar, how BND Tools is loading the jars and the metadata. Then I got the feedback from Thomas Watson that said, it's possible to have an executable jar with a Thomas that's working, but he uses the Spring executable jar stuff to create the executable jar and not BND Tools. So it would be possible, but yeah, I think that's already quite a bunch of what I have built up as examples in here. So I skipped that. So with BND Tools, the executable jar does not work. Yeah, so that's just the overview, what we can do. So with plain OSGi, we can have multiple jars. We can have the executable jar. We can build with BND Tools a custom JRE. And if we have OSGi Connect inside, we can even have the native executable, but the executable jar is not working. That's on the deployment variants. So, containers. Creating containers for a Java application. Size matters. Yeah? Find the right base image. I was looking at various containers or images that are available in the field. First, if I look at the base images, we have an Alpine, we have Debian, we have Ubuntu. And you can already see the Alpine is, of course, most interesting with 7 megabytes as a base image. Debian, even the Bullseye Slim or Minimal, has more than 80 megabytes as a base image. Ubuntu almost 80 megabytes. If we now add the Java runtime to it, or the JDK, you can see that the size drastically increases because the Java runtime itself takes a lot. I see often that people are using a JDK base image because, hey, JDK is, we need a JDK, but why do you need a JDK at runtime? At build time, definitely, but not at runtime. Sorry, too fast. So the most interesting here is the Temurin 17 JRE Alpine with 168 megabytes, which is, well, if you discuss with someone that is programming Go or JavaScript, yeah, okay, we need to take that. I mean, we're not at 10 megabytes, we're at 168, but that's, I think that's for Java, that's not too bad already. I pulled the images actually last Thursday. The numbers were smaller last year. So with the newer bug fixes that came the last year, the size of the images increased by 2 or 3 megabytes, but well, that's how it goes. I mean, we need the bug fixes. And then I compared actually the Java versions, which I found quite interesting. because if you compare the base image size of a Java 11 with the one of 17 and 21, which is actually available since last Thursday, you can see that the size increases. So with the newer Java versions, the size of the images increase. I found it at least interesting. As an interlude, when people are discussing about containers, they often discuss, should we use Scratch, should we use a base image, should we use distroless? Yeah, interesting discussions all the way along. Distroless containers, basically, they are provided by Google. The idea is to have a minimal base image that is secure. So there is nothing in those images that where someone can intrude. Yeah, there is no shell inside, no scripting support. So distroless containers are secure, and they even make they advertise that they are small, even smaller as Alpine. Well, okay, if there's nothing inside, yeah. So the static Debian that you can use for statically compiled languages has about 2 megabytes compared to the 7 of an Alpine, where you can have also a shell and everything. But that also goes up quite fast. So the Java 17 Debian 12 has already 225 megabytes. So compared to an Alpine, it's quite a lot. Compared to the defaults from Ubuntu or Debian, it's less. Yeah, I just added it because I wanted to have the full picture of containers with Java. Yeah, best practices, well, use a JRE, not a JDK, at least if you don't need a JDK. You're saving hundreds of megabytes. Build using multi-stage builds, so you can really have, sorry, that was too fast. So you can have your first container in the multi-stage build that is using the JDK, then you go and copy the result to a smaller container. Yeah, don't run your Java apps as root. Also, if you, quite obvious, probably shut down and handle events to terminate Java applications. That's especially important when we're talking about Alpine, because there is the issue of the sigterm signal that's not fired. So when you shut down your containers that are running on Alpine, sometimes that's not working well. And take care of container awareness. Some of the JDKs out there, or JREs, say that they are container aware. That's, for example, important when you put your container in a cloud system, because the container typically takes resources that you configure. So if you're running on an 8-core machine and you have there your container and say only take 2 cores, it takes 2 cores. Interestingly, older JVMs that didn't have that container awareness, they looked at the running machine. So they took the 8 cores, although the container only took 2, which broke stuff. Newer JVM implementations are container aware. OpenJ9 is making advertisements, especially on that topic, but the OpenJDK is, from what I know, also already aware of this. So how do you build your Docker images, or OSGi images, however, I mean, my example used the Docker. There are 2 approaches, actually. One thing is that you build your image from your Maven build. So you run your image, you run your build, all your jars are created, and then it uses the Docker Maven plugin. So at the end of your build, you have a running container. You have a ready image. You can also run those containers. I call it the Maven or Gradle first approach, because everything is Maven. The other option would be the Docker first approach. That's a bit nicer if you have an inhomogeneous team. That basically means you check out your sources directly in the first multi-stage container step. Then you do there the build and, well, then copy it to the result. Yeah, but then the question is what's your preferred solution. You could even mix those two up, have the Docker first, and then create the final Docker image from the first image. That means Docker in Docker to make it more complicated. For my use case, or for my scenario, I used the Maven first approach because then I could simply run it everywhere. Okay. With my applications, I have these sizes. That's the minimum I need for my application to run. The application I have used is a small command line application with a go-go shell where you can simply type in some custom commands. Pretty easy. And these are the sizes only for the 17. Because I have, for the benchmark, I had to extend these base images about a few features. I'll come to this shortly. How does the benchmark actually work? What was my idea here? I have a benchmark application, and sorry, it was built last year. It's JAX-RS whiteboard. I need to update it then to Jakarta-RS. I have my small application, my small baseline application. I have a shell script around it that simply tries to start that application several times. I'm sending the first request to my application in the shell script that simply says now I start the application, and once the application is ready, I have an immediate component that sends, okay, now my application is ready. It's not 100% accurate, of course, but it gives an indication. Someone typed in the command on the console, and now the application tells me I'm ready. And now I have 2 timestamps and can, Yahoo! Okay, I need to talk faster. No, so I can measure the kind of a startup time, yeah? But for this, I had to extend my images about these 4 topics. I mean, shell script support is important for the GraalVM images. There you can see simply adding, adding the shell script support means I cannot use a Scratch base image because on Scratch I don't have a shell. So I need to switch to Alpine. And you can see there's a big amount, so it's 12 megabytes more. That's because I needed to add the JavaNet module, the JavaNet HTTP module, because I want to send an HTTP request. Additional module that needs to be natively compiled. I have the benchmark support, and even on the Alpine images, base images, I had to add the core util support because I need nanosecond support. Yeah, it's not that fast that we need to measure nanoseconds, but at least milliseconds, and the default is no support for nanoseconds or milliseconds. I don't get a second. I don't get the details on second. So the images increased, and here you again see that the images from 11, 17, 21 they increased. Always about 10 to 20 megabytes. And then I have these results. What does the results actually show? I started with a clean cache. So on every startup, I cleaned the OSGi cache, so it's built every time new. And the second test run is with a cache. So on the first time, or when I created the image, I took the OSGi cache and copied it also over to the final production image and tested it there. Interestingly, it doesn't make much difference if you have the cache or not. Most interestingly was for me that using the cache with the Java 21 was slower than starting clean. I don't know why, or if it was a measurement failure, but you can see it's pretty much the same. And the interesting thing is the smaller we get, the longer the startup time. So multiple jars in a folder with the executable jar, well, some milliseconds. I don't know if that's really, sometimes 100 milliseconds, probably because it's inside a jar and needs to be, the executable jar is an archive, so you need to extract something. I suppose that's the reason why that's slower. But if we create a custom JRE, which we have less stuff to load, but the startup time is slower. And if it's compressed, of course, even slower. So the first takeaway is the smaller we get, the longer it takes, despite the native image stuff. Yeah, of course. It's natively compiled. That's the fastest one with the smallest size. I need to hurry up, but I hope, because I have some Outlook, you grant me some few more minutes. Conclusion, we have all deployment variants in Java also available for OSGi. So even the custom JRE and native and everything is available. That's the first good news. The second thing is, we have different deployment variants, and they have different startup times and runtime behaviors. That's also one thing to which I'm coming shortly. With native compilation, we have ahead of time compilation. So what we have at the end, that's what we have forever. Compared to a just-in-time compiler, that gets better in the runtime behavior over time, because that's what the JIT is doing, the hotspot compiler. For my scenario, where I have a small command line application that I start, it does something and then goes away, I don't care about optimization at runtime. But if we talk about servers, it could become interesting to compare also the runtime performance and the runtime behavior. We noticed that newer Java versions have bigger container sizes. We also noticed that the smaller we get, the longer it takes. And there is a lot of stuff, and there are further optimizations: container awareness, garbage collection, checkpoint and restore. And that's what I wanted to outlook. I also did some tests with OpenJ9 compared to the hotspot. And last year I talked to the guys from IBM because I had some very strange measurements. First of all, the OpenJ9 guys recommend to use the OCI images from the IBM image registry because they have everything in place. The Docker images are there, they are working basically, but some things are missing. I don't know why. They said they are working on this. The recommendation is to use the ones from the IBM, the UBI-based images, and here are, for the completeness, the sizes of those UBI images. Even the minimal one has, the UBI minimal has 290 megabytes, which I find pretty much. And then I did the measurements, and this one was the interesting one that I didn't really understood. So on the side where I started normally, the sizes are comparable to the OpenJDK. But once I created the custom JRE, the startup time drastically increased. So it was about a second more startup performance with a custom JRE based on the OpenJ9. So I discussed with the OpenJ9 guys on the IBM booth, and they said, well, did you use our handy quick start option? I said, didn't know this quick start option. Yeah, you should use this. And really, I then get down to the almost similar startup times that I have with the OpenJDK. So, okay, then I need an additional parameter for the startup. Then I said, yeah, but you can get even faster with a shared class cache. Here, shared classes. Shared classes actually means you're doing some pre-compilation that you can share also with other runtime instances, and it really increases the startup performance. But of course, it comes with the downside that my container gets bigger because additionally to my runtime, I have now the shared class cache. And then they said, oh, haven't you looked at checkpoint and restore in user space? I said, no, I haven't. And last year I was looking quite a lot of in this stuff, but I never found something that's really ready. But now I was able to do some tests. Checkpoint and restore actually means we have an AOT-like startup, like the startup like a native, but we also have the JIT runtime performance because only the startup increased with the checkpoint, but we have at runtime the same thing like a JIT. Okay, cool. Let's have a look at this. There are currently 2 implementations available. Crack. There are nice talks, namely Java on Crack. Sound nice, but Crack actually means coordinated restore at checkpoint. That's part of the OpenJDK. The Azul systems are pushing this hardly. You can enable it via this Crack checkpoint 2 parameter. You can create a checkpoint via API, but they also have command support on your command line, so you can start your application and say, please create my checkpoint and move on from there. That's the OpenJDK stuff. And in OpenJ9, we have the CRIU support. Basically the same. They're using checkpoint and restore in user space. They are using it heavily in OpenLiberty instant on. You can enable it with another parameter, but you can only create a checkpoint via API. That was my first problem on this. I make faster. Okay. No pressure. But actually, that's the interesting topic. The other stuff was. So, where are the issues with Crack right now? I tried it out. I mean, first problem is it's only Linux. For containers, no problem. But that also means it will never become part of an OpenJDK release, because you cannot have it for Windows. There is no CRIU on Windows, so that's only Linux. And when I looked the last time, there was no Alpine Musil variant, so they only had it for, I think it was Jammy. And if you can build a custom JRE, they were unsure about it, because then you need to look how to get the CRIU support on the new images and so on. But the bigger problem was actually this one. They have a limitation on creating the checkpoint that you cannot have open resources or open resource handlers. So creating a checkpoint with an open file reference, an open socket, or any other open resource will fail. I got in contact with them and said, hey, why? What's the problem? They said, well, that's their limitation. I don't know why. And Equinox actually has open file resources to the bundles they are loaded. Yes, James?
Yeah, the problem there is that you have to know what was open and close it before you do the image, and then reopen it at startup.
Yes.
That adds additional complication to saving the image.
Okay. Okay. As I'm way over time, I have to we can discuss this later. Actually, I got in contact with these guys. They said, hey, if you from the OSGi community need support in this, we would love to help you. Reach out to us, let us know what we can do together to make it possible to create even a checkpoint for an OSGi application. And one of these guys is at the EclipseCon, so I mean we can discuss this tomorrow also in the committee rounds, if there is interest from our side to add this support on Crack. Okay, but for me it wasn't dead end because I didn't want to patch Equinox. And then I looked at OpenJ9 CRIU support and I found other issues. It took me a week to come to the current state, which is it's not working. Yeah, only Linux, no Alpine. Is it possible to create a JRE? I don't know. Creating a checkpoint via API, that was the biggest trouble because you can only do it via API. Therefore, this API is only available on Linux. I have a Windows machine. Okay, thanks God, there are dev containers with VS Code, so I created a dev container with a Linux IBM Semaru. I was able to create my code to create the checkpoint. I tried it with the Docker containers. The Docker containers failed because there is no CRIU support in the containers. They told me use the ones from the UBI images. I used the UBI images. Several other iterations later, I got then an exception. Well, the first exception was a 70, which means you're not running in privileged mode. Then I started in privileged mode. Then I get an exception with the code -52, which says, oh, I feel the pressure. That says it doesn't work with Docker. With an x86 machine, use Podman, and then I tried to install Podman, but Podman has problems with corporate proxies. I was not able to solve this by last week. Well, I have two indirections, proxy and VPN. That will be the next thing I'm trying, get Podman running to see if I can then create a checkpoint. Right now, I'm not able to do this. Yeah, and the news. The only new that's probably interesting, if you're talking about Oracle GraalVM, they announced the GraalVM free license with release 23. You can use it for free, even in enterprise, but be careful. There's one sentence in this GraalVM free license that says you can use it for free in business, but you're not allowed to charge your customers for it. For me, that doesn't make it free. All my findings, the presentation, everything is available on my GitHub repo, and I extended the time 15 minutes. 10, okay, good. 10 minutes overtime, but thank you. I hope it was interesting.